Let's start covering some fundamental concepts and terminology of AI, machine learning, and generative AI. This is one of the areas the exam promises to test you on. So before we talk about anything AWS specific, we're going to back up a little bit and talk more about the general landscape of AI and machine learning and where these different terms fit together. So a lot of people throw around the word AI these days, right? It seems like these days when people talk about AI, they're really talking about generative AI, but they're not the same thing at all. You know, when you're using something like ChatGPT or Claude or some large language model like that, that's a very specific kind of AI. AI itself is a much broader term. And when you hear people saying, okay, AI has done all these great medical advancements or whatever, there's a good chance that's really talking about a different kind of AI than a large language model. So let's break that down and what that really means. You can see this little diagram here that kind of encompasses what these terms entail. So overarching through all of these machine learning technologies is the concept of AI at a high level. And that is the simulation of human intelligence in machines that are programmed to think and learn like humans. Now, this can encompass a wide range of technologies, not just including machine learning and generative AI, but also things that are outside of those realms entirely, like rule-based systems, expert systems, and robotics uses AI in a lot of ways. That's a very different thing than, using a large language model to converse with you in natural language. That's much, much more specific. But this whole world of AI and machine learning is kind of under that AI umbrella. So when people talk about AI without specifying generative AI, they could mean any one of a number of things here. Machine learning is a subset of artificial intelligence, which includes a lot of different training algorithms to learn from and make predictions or decisions based on data. So any machine learning system is going to be trained on some sort of data that says, okay, here's some sample data and what it means. Train your algorithms to predict what new things mean based on those previous things that I gave you as examples. So that focuses on enabling systems to improve their performance on a task over time without being explicitly programmed for them. So whereas AI could involve things like expert systems that have specific rules on how to handle different situations, machine learning's just gain that knowledge based on their training data. So they're not specifically programmed for a given problem. There's just an algorithm that learns from the data that you give it on how to answer new questions that it hasn't seen before. Deep learning is a further subset of machine learning. So that's another way that you can train a system to make predictions. There are much simpler ways than deep learning to do this, but deep learning is kind of what's caught on because it's a very general purpose system. It's a subset of machine learning that uses neural networks, or deep neural networks, or deep learning, as you will, to model complex patterns in large data sets. So it's a very general approach where by having these collections of neurons that are interconnected and learning the weights between those virtual neurons, you can model pretty much any machine learning problem there that way. It's a very general purpose approach to solving problems. However, the larger machine learning subset often has a simpler solution to those problems to offer. We'll talk about that. But deep learning is often used for image recognition. You can pump an image into a neural network and have it tell you what's in that image. Natural language processing, of course. It can recognize tokens of words and try to predict what the next word might be, which we'll talk about a lot. And things like speech recognition. You can also feed it waveforms of audio data and have it learn what people are saying and do things like translation and things like that. For things like image recognition, you might use something called a convolutional neural network, or a CNN. For things like time-based data, you might use a recurring neural network or an RNN. Those are specific kinds of deep learning networks that we'll talk about momentarily. But another specific kind of deep learning network is generative AI. And that's a branch of artificial intelligence that's focused on creating new content or data that resembles existing data using a model such as a transformer. We'll talk about what the transformer architecture is very soon. But large language models like Claude or ChatGPT or whatever it is are built on what we call a transformer architecture, which is just a very complicated deep learning network. And it uses those models to generate text, images, music, whatever you want. It's generating some sort of a content that's new based on prior examples that you gave it. Now it gets even more fun. So again, there's a lot of terminology here, and understanding how it all fits together is kind of the point of this section. So like we said, at the top we have artificial intelligence. That kind of encompasses everything in the world of AI and machine learning. And underneath artificial intelligence, we might have machine learning in particular, which again is just a way of training a system based on previous data that you have and using what it learned from that data to make predictions on new data. Then off on the side here, we have other forms of artificial intelligence, which include but are not limited to expert systems, where again, you just have a bunch of hard-coded rules on how to handle a problem, and it has access to a large database of information to draw from. So That's a much more straightforward approach of mimicking human capabilities by just hard-coding a bunch of rules and giving it access to data. It's a much simpler approach. Under machine learning, let's break that down into both deep learning, which are based on neural networks, and also what we'll call classical machine learning or algorithms. There are many older machine learning algorithms that are still perfectly good. XGBoost is one example. This is very similar to a neural network in how it operates. It actually does learn based on kind of the same mathematical principles, but it is a simpler approach and it can run on much less hardware than a deep learning model. And for a lot of problems, if you're just trying to classify data or try to predict whether something is true or false, should I give this loan to this person or not, XGBoost will often do just as good of a job as a more complicated deep learning model will. So that's always worth trying if you have a problem that's pretty straightforward. Some other classical machine learning algorithms that are not neural networks include decision trees, and we'll talk about that in more depth and briefly. But again, it's what it sounds like. It's a decision tree where you start at the top and you say, is this case true or false? Is this data greater than this value? Whatever it is. And you just keep going through this tree of true or false conditions till you arrive at a prediction at the end. So that's another approach. Regression, that's just fitting a line to data. You've been doing that in Excel for decades, right? It's still a valid approach to a lot of problems. Clustering, how do I take a bunch of data and try to figure out what groups that data might belong to? Again, that can be done in a much more straightforward manner than using deep learning. So remember, these classical algorithms are still good, and they're still appropriate for a lot of problems out there, and they're much less intensive in terms of their computing and energy demands. So don't forget they're out there. But all the hotness these days is in deep learning and neural networks, and that encompasses a lot of different things. So for computer vision, we might use a type or a topology of deep learning called a convolutional neural network. We'll get into more detail on that shortly. For time series data, let's say you're trying to predict what a stock price will do in the future, a recurring neural network might work. And we'll see that it's also the basis of dealing with natural language processing. So you could treat a stream of words in a sentence as a time-based problem as well. You have this series of words occurring over time. Maybe an RNN is a way to make sense of those words in a sentence as well. Then we have more generally MLPs, or multi-layer perceptrons. This is just a general deep learning neural network that can be generalized to do a whole lot of different stuff, and we'll look at an architecture of that. And then we have generative AI, which is kind of the focus these days of everything, right? And under generative AI, there's more than one way to do it as well. So these days, transformers is what everyone's focusing on. That's what models like Claude and GPT are using under the hood. But there's other ways of doing it too. There was, before transformers, something called generative adversarial networks, GANs, which could be used for things like making artificial images or deep fakes, if you will. It was also quite effective, actually, but it's kind of fallen by the wayside as transformers have gained more popularity. And then under transformers, there's more specific things you can look at there as well. So we have large language models. Those are things like ChatGPT or any sort of AI chat application that you might see where you're interacting with an AI in plain language, a natural language, and it's responding in natural language. That's what we call a large language model. Large just meaning that it was trained on a large corpus of data. There's also small language models out there too. If all you need is just a model that can string words together in a coherent sentence, maybe you don't need to train it on the entirety of the internet, right? In fact, that's a valid approach that we'll get into later. Sometimes you can augment these systems with your own data and get away with small language models instead of large language models. But when we're talking about things like Claude Sonnet or GPT-4 or what have you, that's a large language model. For images, rather than generative adversarial networks, what's hot these days is a diffusion model, and that's used for generating images from a prompt. We'll talk about that briefly in more detail as well. And there's also multimodal transformers out there as well that can take different kinds of input and produce different kinds of output. Maybe it can mix and match audio, text data, and image data, and maybe output audio, image, or text data as well, and kind of treat them all the same way internally. That's an exciting area of research right now as well. So that's an overview of the taxonomy of AI terminology. Understanding this graph is going to be important because AI, again, it doesn't mean what you think it means. A lot of people throw around AI as sort of a term that's specific for large language models, but it encompasses so much more. There's a lot more to the world of AI out there, and it's all still valuable. So remember that. And let's dive into some more ways to classify AI technologies next. Thank you for watching. If you found this video helpful, please hit the like button and subscribe to our channel, and check out the course linked to in the description. Thanks for watching.